In this video we're going to look at trigonometry. So trigonometry applies to right angled triangles in the same way that Pythagoras' theorem does. And trigonometry can be used for finding an unknown angle or an unknown side. As in Pythagoras' theorem, the way we label the triangle is really important. The longest side is still the hypotenuse, but the other two sides are labelled in relation to the given angle or the angle you're trying to find out. So the side opposite it is called the opposite, funnily enough, and the one beside it is called the adjacent. So the three sides in the right angle triangle are the opposite, the adjacent, and the hypotenuse. Had the angle at the top been the one we were trying to find, or the one that we knew, then the baseline would have been the opposite, and the height would have been the adjacent. Trigonometry is a ratio of two of the three sides. The ratios are fixed and known for every angle, so that these can be used to find unknown lengths and sides. So if we've got an angle of 10 degrees, for any right angle triangle that we can draw with 10 degrees, the ratio of the adjacent to the hypotenuse, or the adjacent to the opposite, or the opposite to the hypotenuse, will always be the same. And that applies for every single triangle and every single angle. So they'll all be the same for the same given angle. Whenever we're using this in our calculators, we need to make sure that there's a D or a DEG on the screen, because our calculators can work with different types of angles, but the angles that we're dealing with are always in degrees, so D or DEG for degrees. And the three trigonometric ratios are sine, cosine, and tangent, or in your calculator they'll just be written as sin, cos, and tan. Although it's not a sin, we're not an RE, we talk about the sine still, okay? Now we'll have used these triangles before if we're thinking about speed, distance, time, or density, or pressure, or something like that. And we can use the same for trigonometry. And we use the acronym SOHCAHTOA to identify which one. So the sine of the angle is a ratio of the opposite to the hypotenuse. So sine theta equals the opposite over the hypotenuse. Cosine or cos is the adjacent divided by the hypotenuse. So cos adjacent hypotenuse. And then tan is the opposite divided by the adjacent. So it's tan opposite adjacent. So the SOHCAHTOA, the first letter in each triple, represents sine, cos, or tan. The middle letter represents what goes on the top of the fraction, and the third letter represents what goes on the bottom every time. And we can use these triangles to work out any of the sides that we're looking for. So if we're trying to find a side, the first thing that we do is we draw and label the triangle. Then we write down SOHCAHTOA and score out the side which is unknown and which side we're trying to find. This will leave a single trig function. Substitute in the values and use your calculator to find the trig ratio, then solve this equation to find the unknown. So example 7, find the value of x in the triangle. So we've got our triangle, now we need to label the sides. And the 12 is the hypotenuse. This is our angle, so the side should be labelled in relation to that. So x is the opposite, meaning that the base is the adjacent. So we labelled our triangle, then we need to write out SOHCAHTOA. And then we score out the ones that we don't know. So we know the opposite, we know the hypotenuse, we don't know the adjacent, so we're going to get rid of all of the three terms that have an A in them. So that's ka and toa. So what we're left with then is so. So represents the sine of theta, and theta is just the angle, is the opposite divided by the hypotenuse. So we fill in the information we have. We've got the sine theta, the angle is 50, the opposite is x, and the hypotenuse is 12. We can go to our calculator now and press sine 50, and we get 0.7660, and that equals x over 12. So to get x on its own, what we need to do is multiply through by 12, and if we do that, we get 9.19 is equal to x. So x then is 9.19 centimetres. We know in a right angled triangle the hypotenuse is the longest side. In this case it was 12. Our answer is less than 12, so it looks as if we've done something that seems sensible anyway. But of course our answer is right. Example 8, in the triangle ABC, angle B is 90 degrees, angle C is 27 degrees, and BC is 12 centimetres. Find the lengths of AB and C. So the first thing we need to do is draw a triangle. So we've got the triangle drawn, and what we need to do is use the information. So it says angle B is 90 degrees, so that means the corner is B, and then A and C don't really matter which way around we do them. Angle C though, so that's the angle down at the bottom, is 27 degrees, and we're told that BC, so that's the line connecting B to C, so that's the base, and that's 12 centimetres. And what we want to do is find the other two sides. So let's call it X and Y. So first of all, for X, we need to label the sides. And the AC is the hypotenuse, BC is the adjacent, and AB is the opposite. So if we write out SOHCAHTOA next, and then the side that we're not interested in at the minute is the hypotenuse. So we're trying to find X. So we need these two sides, which is the opposite and the adjacent, which means we're forgetting about the hypotenuse. So SO has the hypotenuse and CA has the hypotenuse. So we're looking for TOA. And TOA means tan of theta is the opposite over the adjacent. So if we put in the information there, we get the tan of 27 equals x over 12. Using the calculator to work out the tan of 27, we get 0.5095 equals x over 12. And if we multiply by 12, we get 6.11 is equal to x. So we worked out the length of AB. To work out the length of the hypotenuse, we could use Pythagoras' theorem, because we've now two sides and we want to work out the third. But rather than that, let's go and do it using trigonometry again. So we're going to label the sides. It's still going to be the adjacent, the opposite, and the hypotenuse as before. And we need to write out SOHCAHTOA. Only this time we're not interested in the opposite. So we're going to get rid of SO and we're going to get rid of TOA because they each have the opposite involved in them. So now we've got the cos of theta equals A over H. Filling in the information, we've got the cos of 27 equals 12 over Y. On a calculator, the cos of 27 is 0.8910, and that equals 12 over Y. Now because the Y is on the bottom, what we need to do is multiply up by that. And we're going to get 0.8910y equals 12. So y is going to be 12 divided by 0.8910, and that works out to be 13.47. Example 9, in triangle ABC, A is 90 degrees, B is 52 degrees, and BC is 12. Find the lengths AB and AC. So we've got a right angle triangle. We need to label the sides. The right angle is A, and then B and C are going to be the other two sides. Angle B is 52, and BC is 12. So we know the hypotenuse. Find AB. So let's call it X first of all. So first thing we're going to do is think about SOHCAHTOA, and we're also going to label our sides. So the opposite is the one opposite the angle. The hypotenuse is the length BC, and then the adjacent is the one beside the angle. We're not at this stage interested in the opposite, so we can get rid of SO and we can get rid of TOA. And what we've got then is CA, which is the cos of theta, is A over H. That means we've got the cos of 52 equals x over 12. The cos of 52 works out to be 0.6157. And then if we multiply by 12, we get that x is going to be 7.39 centimetres to 2 decimal places. Then we can go again, and this time we don't want to work out the adjacent, but this time we are looking for the opposite. So our first step then is to write out SOHCAHTOA. And we're not interested in the adjacent, so we can get rid of Ka and Toa. And we've got sine, so that's sine of theta equals O over H. That's the sine of 52 equals Y over 12. Sine 52 is 0.7880, which is Y over 12. If we multiply up by 12, we get that Y is going to be 9.46 centimetres to 2 decimal places. On example 10, the diagonal of a rectangle is 15. It makes an angle of 36 with the smaller side. So we've got our rectangle drawn and the diagonal, so it's going to be 15. And it makes an angle of 36 with the smaller side. So the smaller side is going to be the height in this case, so the angle at the top is 36. Obviously the angle at the bottom is a right angle because it's a right angle triangle, and we want to find the length, find its length and width. So we're going to have an x and a y. So we need to label the sides, and related to the angle 36, then the y is the opposite, x is the adjacent, and 15 is the hypotenuse. So if we're trying to find x, then we don't need the opposite. So whenever we've got SO, Ka and Toa, we get rid of the ones with O, so that's SO and Toa, and we're left with Ka. Ka is cos theta, is adjacent over hypotenuse. Substituting in the information, we get cos of 36 equals x over 15. Calculator out then, cos 36 is 0.8090 equals x over 15, and then multiplying by 15, we get 12.14 is equal to x. So now what we want to do is look at the finding the opposite side, so that was y. So this time we're going to score out the x and the adjacent. So SOHCAHTOA again. We don't want the adjacent, so we're going to get rid of Ka and we're going to get rid of Toa, and what we're left with is SO. SO is sine theta equals O over H. Substituting information, we get sine 36 equals y over 15. Sine 36 is 0.5878, and then multiplying by 15, we get that y equals 8.82. We're asked for the area. Area is going to be x times y, which is 12.14 multiplied by 8.82. Which is going to be 107.04 squared centimetres. Just want to go through one more example on this, and that's another one where we're trying to find this hypotenuse. So the first thing we need to do is label the sides. So the 10 is the opposite, the y is the hypotenuse, and then the height is the adjacent. So we need to write out SOHCAHTOA. And we don't know anything about the adjacent, so I'm going to get rid of Ka and Toa, and we're left with SO. So means the sine of theta is the opposite over the hypotenuse. Putting in the info we have, we get the sine of 40 equals 10 over y. So we haven't had a lot of examples here where the unknown is on the bottom, but we do the same technique that we've been doing up to now anyway. So the first step was to work out what the sine of 40 is, and that's 0.6428 is 10 over y. At this stage we always multiply it up by the denominator, so we'll do that again. We'll multiply through by y, and we get 0.6428y equals 10, and now we'll divide by 0.6428, and when we do that we get y equals 15.56 centimeters. Okay, so whenever we get to this stage where we've worked out the sine or the cos or the tan of the number, we always multiply up by the denominator. If the denominator is a variable or an unknown, we then have to divide down by this number, whatever it happens to be. If the top was the unknown, once we multiply up by the bottom, which is a number, this is something that we'll be able to do, and then we'll be left with our unknown, and we'll have got the answer. So we do this dividing method whenever the bottom is the term that we're looking for in this fraction.